So thanks for having me. My name is Ben Wasovich. As he mentioned, I'm primarily a web developer, and I got into Rust, about 4 or 5 years ago. So my talk is about making web UIs easier with Leptos, which in this case means that it make it easier to build websites and web apps, right? These are my socials if anybody is interested. Other than that, I've been a Leptos contributor for about 1.5 years, core contributor / lead maintainer for about 4 or 5 months. I know that doesn't sound like a lot, but Leptos has only been around for about 15-ish months, so I joined in pretty early, as far as it goes. Shout out to Greg. He is the founder of Leptos. He couldn't be here today. He's been instrumental in helping get me onboarded and in building the framework itself. So if he's out there somewhere, I don't think we're live streaming this, but thank you, Greg. Front end is more complicated than back end is a thing that I hear a lot. How many of you believe this? Okay. I'd say at least half of you, a little bit more than that. I think that's a little bit unfair. Backend certainly has its challenges, and I think a lot of that is self-inflicted. The JavaScript environments, web frameworks in general, have been fast-moving, have been inconsistent, have changed radically, very radically over the last few years. So, very complicated thing. It makes me wonder, how we got to this point. I guess we'll never really know. Leptos is a full-stack web development framework. That means that we have things to send data from the server to the front end, but we primarily help you build websites with interactivity, with buttons and forms that do things and change bits on the page. This part's going to be a little bit harder. Let's see if I can see the mouse. I like to show people some of the sites that have been built with Leptos. We have a surprising number of commercial users that have adopted us, which is surprising to me, but they seem to like it. So we got Pattr, which is a Kubernetes platform. They built their whole marketing site and their control plane in Leptos. Looks pretty good, right? The California Beach Volleyball Association, pretty random site, but I do enjoy beach volleyball. Chris Biscardi's Rust Adventure platform. Chris has been an early adopter of Leptos and a good friend to the project. He rebuilt his whole video workshop platform in Leptos. And he seems pretty happy. At least that's what he's told me. I hope not. This Week in Bevy is also Chris Biscardi. We wrote that in Leptos. A little more interesting is a recent development, a 31,000 product e-commerce store. They've recently, and my internet is not amazing, they recently rewrote their site in Leptos. So, very exciting time for us, and we look forward to more people using it. Let's see. We have a bunch of design principles that are primarily interesting to people that build web frameworks. Stability and performance. We want our APIs to be consistent. We don't want that churn that the web front-end industry has seen. And we've done a pretty good job at that. We want it to be fast. We don't care about performance. It should feel like a Rust app. There are a lot of projects that will try to create their own DSL or kind of expand on the existing language to provide features. But we want to stay consistent. So if you know Rust, you know how to program. Or at least you know the language you'll be using to build a Leptos site. Compile time, not runtime, is good for performance. It's good for bundle sizes. Generally works out for us. We make some sacrifices to keep things simple, make developers' lives easier, because God knows it's hard enough already. And we'll lean on the things that are built into the browser, HTML first, if we can, right? We're a WebAssembly framework. For those of you who haven't used WebAssembly frameworks, basically that means that anything that the browser needs to do will be compiled from Rust into WebAssembly. What exactly gets compiled into WebAssembly depends on your rendering mode, which we'll talk about in a little bit. But that's generally what they mean with WebAssembly. With WebAssembly, you are dependent, for the most part, on JavaScript to provide that interface to the browser APIs. Unfortunately, there's no way around that, but we actually haven't found it that limiting. So it's kind of worked out for us. Client-side rendering is one of the things we support. It's the simplest rendering method. Everything that builds a web app is compiled into WebAssembly and then sent down as a static file that the browser then loads. It's easy, and we'll talk about why you might want to do that in a little bit. Here's an example of a Hacker News clone we built with client-side rendering and Leptos. Don't pay any attention to the times there. We made it way slower so that this was obvious. It does not take 6 seconds to load this, most of the time. So you can kind of see here, we load our HTML and CSS. The big line in the middle is the WebAssembly file. It's about 650 kilobytes. But one of the things you notice about client-side rendering is that this last little bit here is data fetching. So we have to load all of the WebAssembly to do the data fetching. So that kind of does delay your time to interactive, the point at which a user can click on something and expect it to happen. Whoops. Nope. And everything gets put into the WebAssembly bundle, so that makes your WebAssembly bundle larger. But the benefit there is that once you've downloaded that bundle, they don't have to download it again. That's kind of the older method. I don't want to say React made it popular in like 2006, and they're still using it a little bit. Server-side rendering is kind of where everybody seems to be going again, server-side rendering with hydration, which is the idea that you will render the HTML for the page on the server. You will start all of the data fetching and async processes, and then you'll kind of populate it into the HTML once it's loaded dynamically when it's done. And this is the same site with a server-side rendered example. If you look at this, the WebAssembly is still the largest one here, but there is no post-WebAssembly data fetching step. That's actually built into the initial HTTP request. So it starts immediately, which has its benefits. But it requires a server. So let's try to do a basic Leptos app. I don't think I have time to build it from scratch, but I want to take the time to kind of explore it a little bit, explain how it comes together, kind of how our reactive system works, and play with it a bit. And this is going to be a challenge because behind me, let's see. Okay. All right. So I've pulled in our basic starter. It's actually even more simple than our basic starter because it has little in it. But as I said, since we don't have time to build it, we're just going to go into the complete one. What? That? Oh, that's why. Okay. So this should look pretty familiar to Rust developers. It is a single Rust crate. There's not too much interesting here. Assets are in the public folder. We've got styles in the style folder. And we've got, Rust source files. This is a server-side rendered app. We support a wide variety of servers. This one's using Axum, but we've got people using Actix, Spin, Cloudflare Workers, AWS Lambda, you name it, somebody's probably done it, or at least it's possible. We've got a pretty inventive community, right? If you look in the main, you can kind of see the names of things that I have reused from the previous conference. but this is a pretty typical Axum main file. We start our server, we load the configuration, we put things in state, all of that fun stuff. But we're going to spend a little bit more time in our app file. So Leptos uses components much like React does. A component is just a Rust function that returns impl into view and is annotated with the component macro. It should be pretty straightforward to write. Inside of that, we've got our regular Rust stuff. You can put whatever Rust stuff you want here. And we've got our view macro, which generates our RSX. RSX is what I call the JSX, but with Rust in it. You can kind of see it is, well, maybe not in this one. In this one, maybe a little. It is basically regular HTML with little bits of Rust interspersed in it. Like this, for example. Anything in curly brackets is a Rust. You can put functions, you can put variable names, you can put it to your heart's content, right? So let's see if I can run this. Cargo Leptos. I'm going to be in trouble if I can. Uh-oh. So compile time is something people think about. The initial compile time is a little bit slow, right? It takes a couple minutes usually. But once you've done that, we do have hot reloading, which lets you usually see changes to this stuff instantly. But even if the hot reloading doesn't work, which it only works for changes to the HTML and CSS, typical times for incremental compiles are around 2-ish seconds. So it's not terribly inconvenient, at least so far that I've found. I'm sure if you're used to instantaneous changes in, say, Vite, it might be a bit of an adjustment. Sure? Yeah. Right. So there are a few reasons, there's a few places you don't have to use curly braces. You have to use curly braces for things that aren't easy statements. Like here, this will get auto-completed. This is an update count function. But if I had something a little more complicated, I could do like move, update count, and do a bunch of random Rust stuff in here. You don't always need it, but sometimes you do, is basically the version. And I probably shouldn't have deleted that. Okay, we've compiled, and we've got an error because I'm already doing it. That's not right. Let's try to kill some things. What port is it using? 3000. Sorry about this. This always happens to me whenever I try to do something on the internet here. Let's try to rerun that now. Still no. I guess now is the point where I Google how to figure out what's using port 3000, which is embarrassing, I know, but how to find... I can't... Actually, I think I might know. Hold on. That would probably do it. I actually think this is Obsidian, which has started sitting on my port. There we go. All right. See if I can see my mouse here. Let's open that. So this is a very simple app that we can play with a little bit here. The homepage component, you can kind of see here, has a resource which will load the count from the server. The count here in this case is 0, I suppose. But if I hit update, it will update. And since it's stored on the server, if I reload this, it will persist. The neat thing about this is part of our reactive system and fine-grained reactivity is that if I update this, it knows to only update this little bit of the view. It won't rerun the counter. It won't re-render welcome to Leptos. It is, at least I think, a simpler method than React, which tends to reload the entire component or page and then diff them together, right? Fine-grained reactivity is the idea that only this little bit is linked. And you can kind of see that link here in the create resource. The first argument to this is the update count function, which we're asking it to give us the version of, and .get, which is a signal, because this whole thing's a signal. So we basically say that if I update the count, then we're going to rerun the create resource, and then in the view itself, if I were to go down here and find it, you should see a little call to count resource here, right? And that's pretty handy when it works, which is almost all the time, right? The other thing we like to do, I mentioned HTML first. This is an action tied to an action form, which actually works out to be a regular form. So there's nothing really complicated about this. We send the count with a name of increment by and a value of initial increment, which in this case is 7. We send it to the server, and we get back the result, which is handy. One of my favorite things about Leptos is server functions. This lets us run things on the server from the client as if we were running it on the client, which is always nice. What this actually does is it will create its own API endpoint for you, and all you have to do is define a Rust function with whatever variables you want to take, and return some type with a server function error, a result I64 server function error in this case. Annotate it with the server macro, and you're off to the races here. So if I were to open up the network inspector, sorry I'm turning around so much, we'll reload this page. We'll see how this does. If I rerun this, you should see it in action. Yeah, so we've got a call to update count, which, as we mentioned, is updating the count here. And if I look at the request, you can see that it is sending inform data increment by and the number 8, because that's what we're incrementing it by. And if you look at the response, you can see it was just 16. And then, as I mentioned, because this is HTML first, if WebAssembly and JavaScript were disabled, this would still work because it's a regular form. But since WebAssembly in JS is not disabled, it will be a little bit smarter and do the fetch without reloading the page, right? The reactive system's fun, as I mentioned, because you can only change the things, the little bits of it that matter. And I could spend a lot of time talking about how that works and kind of the intricacies of it, but I won't bore you with those details because I want to get to lunch eventually. And yeah, that is the basic structure of a server, of a Leptos app, right? It is a number of components. We've got our own little router that runs on Axum, called like a regular handler, and we can manipulate data in that way. So it's one of the quickest examples. I would encourage you to check out our Leptos book or our Leptos docs, or our Discord. We have tons of nice documentation that our community has worked quite a bit on. So I hope you will not be too stuck with that. And we'll go back to the slide here. Back to presentation mode. Okay. All right. So now we get to the fun part of my talk, right? We talked a little bit about how it works and kind of the structure of an app, but I want to tempt you, right? Why would you reach for Rust for a front-end web app when, JS is the traditional method, right? Why would you choose Leptos over React or Next or Svelte or Vue, or there's a lot of those. And there are some good reasons, but before I get into those reasons, I want to talk about some of the things that I consistently hear whenever I talk about how Leptos is a WebAssembly framework. The first one is that the bundle size is too big. This is partially true. The bundle size will be a little bit larger on a comparable site than a JS equivalent, but WebAssembly is more efficient to load. So I can load about twice the amount of WebAssembly that I can JavaScript in the same amount of time. So that helps. And also, we've been reducing this quite a bit. So it's unlikely that this is going to be a major factor for you. Startup time is slow. I mean, this is technically true, but with things like server-side rendering, we've gotten pretty fast. If you build your site with progressive enhancement, then as you saw with the action form, or at least I talked about with the action form, it will work without the WASM being loaded, which is always nice. As I mentioned earlier, DOM access is not something that we have, but it would be nice, but we're not limited, and the compile time's pretty fast. Performance, this one's always fun. I don't think many of you are going to be able to read that, so I'll try to summarize it. I made it bigger this time, but this is the JS framework benchmark that all all web frameworks typically end up on. This is the most common bench that we use. And you can kind of see in the middle here, we've got Leptos, and then on the right we've got React, Alpine, Vue, and on the left we've got Vanilla.js. So that's kind of the speed here. Vanilla.js is the fastest, Leptos is doing pretty well, beating Vue and React, and then Alpine, which really shouldn't be used for this, is kind of on the end, which is always nice. Because basically this tells us that as far as rendering pages go, it's not a limitation. You know, timed interactive is not a problem, and this all usually works out pretty well. I like to do a more real-world circumstance, so I did a little test with my blog. I took my blog and I built two versions of it, one in Remix, which uses React, and one that uses Leptos. As similar as possible, they both have an SQLite database, they both have the same posts, they both have the same HTML and CSS, and I measured how long it took to get the page under different levels of load. The home page fetches blog data, some post metadata, checks if you're logged in, and renders the HTML. Test hardware, I threw it on DigitalOcean, the details are here. Suffice it to say it's dedicated and unlikely to be a variable, I believe. This is the Remix and Express.js version. I love this graph because it's so colorful. On the top, we've got our success percentage, the number of the percentage of requests that return to 200, and you can kind of see that falls off after a while. And then on the bottom, we've got a graph of the latency, the time that it took to load the page, and the number of requests per second that I was stressing my server with. And for Remix, you can kind of see that it does pretty well, all the way up to about 100 requests per second, and then it starts to go up really fast. And that's actually a little bit before it starts to be unsuccessful, which is kind of interesting, but not terribly relevant to this example. The most common, and this is a heat map on the bottom, so the orange is, or yellow, I guess, is the most common, and then it kind of goes up to blue, where it's the uncommon. So that's Remix. This is Leptos. You can kind of see you still got that fall off at the end, but the time doesn't substantially change until about 1,000 requests per second, 10 times more requests than the React Remix version. And a lot of that has to do with how much more efficient Axum is over, say, Express.js, but I like to think that Leptos plays a little bit in there. Also of note is that on the left here, the latency, this one is a lot more fine-grained than the other one. This is 10, 100 milliseconds, 1 second, and on the other one, this is the same. Maybe I fixed that. Good for me. But yeah, 10x is a very substantial increase in traffic for an individual server. So if I was going to be building, say, something that I expected to have load, I could save a lot of money by choosing Leptos, by choosing Rust here. 50% reduction in page time is a little bit less significant. You can kind of see here that it took about 5 milliseconds for Rust and about, 20 milliseconds going down to about 10 for Remix. So a little bit of benefit is always nice. You can use Rust type system and tooling. Cargo, Rust format, Leptos format, all nice tools. Cargo Clippy, all nice tools. The JavaScript tooling ecosystem, NPM, Yarn, PNPM, Prettier, ESLint, Biome. There's so many of them, and they're changing rapidly. But I'm very happy with the Rust system. It works out well for us. You can reuse the types from your Rust backend in Leptos with no effort. Just import it, in both places. And the server function macro will make sure that that data is correct on both ends. So really nice. I don't have to write any more Zod endpoints. Although since I actually do a lot of React, so I do have to write a lot of Zod endpoints. The other thing that I found that was interesting from our perspective, at least, or my perspective, is that a lot of the users have reported to us that they are able to build more complex apps with Leptos with less resources than you would with React. And I think a lot of that comes to how much effort, how much the Rust tools and the Rust compiler keep track of you in the Rust type system. Right? If all of those things are encoded in the type system, you don't have to keep a mental model of those. You don't have to worry about them being null at some random point. And that's really come out nice for us. I've got a bunch of testimonials from various users of Leptos in here, mostly from the people whose sites I showed you earlier. Patter found that their time to produce new features went down significantly because they didn't really need to do much debugging once they've built it. It is a little bit slower to iterate with Rust. You have to compile it. You've got to write more expressive types. But it's more likely to work once you do, at least from their experience. Chris Biscardi said a similar thing. He said basically that he is able to build more complex apps with less effort, with less cognitive overhead, right? Alex from the California Beach Volleyball Association likes the performance because, at least in California, our beaches don't typically have the best Wi-Fi or cellular most of the time. We've got a lovely ecosystem and community. We've got an active Discord server. We've got a wide variety of Leptos libraries, from component libraries to alternative view macros to you name it. We probably have a Leptos equivalent. And that's something that's really nice for me, because when I started originally, it was just Leptos. We didn't have any utility libraries, anything nice along that. And now we're starting to see this development happen. There's a great list of them on the Awesome Leptos page, or you can check out our Discord under the Libraries channel. We've got a lot of them. So, Leptos 0.7 I am excited about. Our alpha is out now. It is a complete rewrite of the reactive system to make it better, to make it trait-based. It doesn't really affect you guys as the end users, though, because the API is almost the same. But I'm excited about it, at least. The other thing we're doing, which is fun from a UI developer perspective, is that we're taking the fine-grained reactive system, the reactive graph, and we're making it modular. So now you could take that and say, put it on top of GTK or ICED or whatever that you can define the trait for that says this is a text node, this is an element, here's how you do a bunch of those things. So I'm excited for this because this means that maybe I could integrate with, say, JAX' Blitz or Qt or TUI or whatever. And you don't have to worry as much about the state problem that you have to worry about when you're writing one of these frameworks. So very excited about that. And we've got some ergonomic and performance improvements. The speed will increase a bit. The bundle size will go down a little, which is always fun. I hope I've tempted you to try it at least. Server functions, performance, infra costs, the Rust type system, and being able to build more with less. I was hoping to show one of the examples from Husky, which is the largest open source residential Canadian property database built entirely in Rust. That with back end, they had to rewrite for performance, and their front end, they're using Leptos to reuse all of those types. And that's actually done with a two-person team. One of them is part-time, which is a very impressive thing to build with such little resources, right? But unfortunately, their site is down, so I didn't think it'd be good to send you to them. Join us, as I mentioned. We've got a website. You can find links to all of our documentation, our Discord, our books, GitHub, you name it. And that's the end of my talk. If you have any questions, I'd love to hear them. If you find me later, I have Leptos stickers, and I'd love to chat more with you in the future.
All right. Thank you, Ben. Any questions from the audience? Again, we'll take a couple questions.
Hello, nice presentation, thank you. One question, when you mentioned the California beaches, that they often have issues with the internet, something came to mind. Is there support to storing the state on a client side in case of offline, and then like syncing it later with server?
So that's a good question, whether you can store the stuff offline. Like traditionally, I think of like a progressive web app or something that has kind of that separation point where if you don't have internet, it will, excuse me, it'll still work, right? And the answer to that is no, it's not built in yet. A client-side rendered app would work very well for this application because it would have the WebAssembly already, but we don't have a great way to make the data fetching switch from the server or whatever other resources you need to a local one. I don't think it'd be hard to build, but it's not built in. So.
Okay, any other questions?
Nice talk. Why did you call it Leptos, or whoever called it? What does Leptos mean?
So leptos is a Greek word that means airy or light. It was chosen by Greg. Most people seem to think it means leptospirosis, which is a disease you can catch from rodents. It doesn't mean that. So, you know, Greg is classically trained, so I think that's why he chose it.
Okay, let's take one more question.
Is there something like in Dioxis they have this kind of live view alternative in a way? Is that something that you have in Leptos as well, or more broadly, how is your server sent events or WebSocket support?
Okay, so the question was, how does the server do WebSockets or events? Does it have some kind of live view thing like Phoenix does? The answer to that is generally we stay out of your way, right? If you are using Axum or Actix, they all have great libraries to generate and handle WebSockets that you can really easily integrate with Leptos. If you're using client-side rendering, I guess you'd have to, well, can't really use WebSockets then, other than a client which you could integrate. We don't have, you kind of need a virtual DOM, which is how Dioxis does its rendering, where it renders the component once and then renders it again and diffs it, but you kind of need that to do that kind of live view, and the fine-grained reactive system doesn't really work with that. But we could build a simple one to do that, but so far we have not much interest.
All right, thank you, Ben. Thank you for everyone, and let's continue with the next speaker. Thank you.
Thank you.